Okay, good morning. Welcome to
FamilyMath587a.
FamilyMath587. So yesterday we watched another one of Grant Sanderson's calculus videos, and he was explaining this concept called the derivative. And one of the things he was looking at is a square with side length x.
Okay.
And what was the question he was asking about this square?
So I think it was, how does the area change if you increase x by a little bit?
Yeah. How does the area change if you increase x? You make a new square whose extra side lengths are dx. Right, we're having some marker issues this morning. Dx. So the side lengths now are x plus dx and x plus dx on this side. So we have a new square. And what is the area? Can you tell me what the area of this new square is?
It's dx squared.
Sorry, the whole new square.
It's x plus dx squared.
That's right. It's x plus dx squared, which is what?
So that's x squared.
Okay, so there's an x squared. Where is that in the picture?
We have this. That is the x squared.
This is the x squared.
And then we have 2 times x, 2x dx.
So plus 2x dx.
That's
Where is
these
that?
2 parts here.
That's those two rectangles.
And then plus dx squared.
Okay, so this is the new area. And when you're trying to figure out how it's changing compared to the old area, what was the old area?
It was x squared.
It was x squared. So we're going to look at the difference between the old area and the new area.
Okay.
Change. Okay.
So it's 2dx plus dx squared.
So the
Or 2x
the
dx.
d, I'll call it d area, the change in the area,
Okay.
is 2x dx
Plus dx squared.
squared. You gotta be careful with that. Dx quantity squared. And we're trying to find the change in area per change in volume, so we divide by dx, per change in length, sorry. So we divide by dx, and we get, I'm close to out of room, so I'll just put it over here. The change in area per change in length is 2x.
X.
What's dx squared divided by dx?
It's dx.
Yeah, it's dx. And this is a very small change, especially as we start sort of making the changes small.
Yeah.
Really small.
So we just say, what Grant says is you can just ignore this.
Okay.
And the change in area, when we increment by a little amount, is just 2 times whatever the original side length was.
Cool.
So it's actually pretty neat. And he gave some numerical examples and showed you how that was working. And he even gave some numerical examples that helped us see why dx squared was really small.
Yeah.
Yeah.
It's like 0.001.
And so at the end, he was saying, hey, there's actually a power rule. So when we have the derivative of x to the n was what?
It was n times x to the n minus 1.
And he gave 2 challenge problems that we're going to work through in the second 2 videos here.
Okay.
So first was x to the minus 1, which is also can be written as what?
1 over x.
Yeah, so we're going to try to find the derivative of 1 over x, and we wonder if this might be what?
So it'd be minus x to the 0. Or minus x to the minus 2.
Right, minus 1 times x to the minus 2. Just following this rule. Does this rule also work for negative numbers?
Yeah.
And then he gave the square root of x as another challenge problem.
So
And what is the power on the square root of
it's
x?
x to the 1/2.
And so can you tell me, if this follows the same rule, what would the derivative of x to the 1/2 be? I shouldn't say
So
equals, I
it's-
mean the derivative.
1/2. It's half of x. To the negative 1/2.
Yeah. So if this follows the power rule, it should be the derivative of x to the 1/2 should be 1/2 times x to the minus 1/2.
Cool.
So he gave these as 2 challenge problems, and we're gonna work through them.
Okay.